Hey guys, this is Shelby with the Rogers Public Library. So this week for Full Steam Ahead, I wanted to talk to you guys about pollution, right? And pollution is just stuff that's in the environment that's not supposed to be there. And this stuff that's not supposed to be in the environment, we call them pollutants, right? Pollution isn't really a new issue, right? So we actually have geological evidence from polar ice caps of pollution dating all the way back to the 1570s, which is almost 500 years ago, right? But it really the started being a much larger problem in the 19th century during the Industrial Revolution when people were burning a lot of coal and running a lot of factories and there weren't a lot of regulations on the how they use chemicals or how they release them into the environment. In the United States and Canada and other parts of the Western world, like Europe, pollution has largely become less of an issue since the 1970s because we put a lot of regulations in place to lessen the effects of the stuff that we're releasing into the environment. But it still is a big issue in lots of different parts of the world, including parts of the United States as well as places like China and India. Pollution, it's a really kind of broad thing, so it might help to kind of break it down into different types of pollution or different types of pollutants. Right, so one way to look at this is stock pollutants versus fund pollutants, right? So stock pollutants are things that are bad in any quantity in the environment. They can't biodegrade, right? So this is things like plastic and mercury and radioactive material, right? These things just persist, right? They can last for hundreds or even thousands of years. And because of that, even if there's just a little bit, even if you just release a little bit of these pollutants into the environment every year, it's just going to keep building up and it's not going to ever really go away, at least on human timescales. There's also fund pollutants. So these are things that can be absorbed by the environment, including some that are present in the environment naturally, like methane or carbon dioxide, right? So plants need carbon dioxide in order to photosynthesize, but if there's too much, it can start causing problems like heating the world up, the greenhouse effect, right? You can also talk about point and non-point pollutants, right? So point pollutants are pollutants that we can trace to a specific source, like a factory or a sewage treatment plant. And non-point pollutants are things that are more dispersed, that we know maybe the general area where they're coming from. We can't trace them back to a single location. I mean, this includes things like agricultural runoff, which we're going to talk about in a little bit. Another way of grouping pollutants is talk about pollutants that are in the land or in the water or in the air, right? And you know, these aren't like categories that are sandstones, right? Things that are in the soil, for instance, can get picked up by rain or by wind and end up in the air and the water and get spread. And because, like we talked about the weather, about how there's these big currents of water and air, pollution from one place can end up somewhere else, right? It's not just stuck in one location. Yeah, and so pollutants obviously they hurt the environment, but they can also make people really sick, right? So especially things like mercury and radioactive material, right? They can cause really big problems for humans as well as for animals and plants and the environment in general. Yeah. So what about pollution in Arkansas, right? So Arkansas, it's we actually have really good air quality here compared to other states in the United States. But there are some issues, right? One issue that happened recently was there was a really big fire in 2018, right? And this is called the Bella Vista Stump Dump Fire. And basically what happened is there was a big pile of dead trees that caught on fire and it burned, not just for like a day or a week even. It burned for 11 whole months, right? Which is kind of crazy, right? And it cost $4 million to put the fire out. And during the time, the 11 months that it burned, it released a lot of really nasty chemicals into the environment, including benzene, which can give people cancer. Another environmental issue here in Northwest Arkansas is agricultural runoff, right? So what this is basically things like soil and fertilizer that get picked up by rain and end up in waterways. And, you know, right? So the thing about fertilizer, it has nutrients that are supposed to help plants grow, including things like phosphorus. And, you know, the fertilizer is really important to make sure that you get nice, healthy crops and a lot of crops. But it's also kind of hard to know when exactly is the best time to fertilize plants because the weather can change or you might put too much on. And then some of those nutrients end up not just fertilizing crops, but they end up fertilizing algae that live in waterways. Right? Because the thing that really limits the growth of algae in general are two chemicals, nitrogen and phosphorus, that are the main components or some of the main components of fertilizer. And right, so algae is good, right? Fish eat it. It's an important part of the ecosystem. And although there are some algae that can produce toxic chemicals, and that can be a problem. But in general, if you just have more algae, that isn't necessarily a bad thing. What is a bad thing is that the levels of algal growth aren't sustainable. And so when this happens, when the algae population goes up and blooms, and this is an image of what an algal bloom looks like, right? So this is in the Baltic Sea, which is in Europe. It's kind of far away, but it's just a really nice picture, and I thought I would share it with you guys. But the real issue with algal blooms is that when algae dies because they don't have nutrients to support themselves anymore, is that the decomposition process uses up a lot of oxygen. And things like fish and some crustaceans need oxygen to live, right? Which, right, you know, you need oxygen to live. And so if too much algae dies off at once, then the fish can't survive, and you end up with what's called a dead zone, right? There's just a big area of water where there's nothing or very few things that are alive. They can't sustain life anymore. In this process of, you know, too much nutrients in water, this is called eutrophication. It's kind of a big word. I figured I'd write it down because it's a mouthful. So I looked into this, and it looks like we have had at least one algal bloom here in Northwest Arkansas, and this was in 2015, right? So there's a lake just east of Rogers called Beaver Lake. And this is the main water reservoir. That most of the drinking water that people drink in Northwest Arkansas comes from there. And in 2015, this guy named Orglina volvox started blooming in the water just because of runoff, right, to this eutrophication process. Right. So this is a type of algae. It's a colony, right? You have these little single-celled organisms that kind of group together in these circular masses. And right, so this was kind of a minor issue, right? It made the water taste funny for a little bit, but really, this algae is relatively harmless. It doesn't produce toxic chemicals, and we haven't had any algal blooms since then, which is really nice. But another problem with runoff is it doesn't just affect us here, right? So we live in something called the Mississippi River Drainage Basin, right? So this whole area from here to here all drains down in Louisiana into the Gulf of Mexico. And this little white star, that's us. So anything that ends up in the water here is going to end up in the Gulf of Mexico. And because there's so many farms in this area, there's a lot of agricultural runoff. And it creates a really big algal bloom and a really big dead zone off the coast of Louisiana. This is what the dead zone looked like in 2020 last year, right? And this is actually smaller than it's been in recent years, but one of those reasons might have been when they took the data, less so than it actually being not as bad. It's kind of a complicated issue, right? In the dark red areas, those are where there's very little oxygen at all. And then, but even these lighter areas, the yellow parts, those are there's still really low levels of oxygen, right? Right. So for our experiment this week, I'm going to do something where we can kind of look at environmental quality. And an easy way to do that is to test the acidity of rain, right? So I collected some rainwater. I got this one on the 28th of April, right, when we had that nice storm. And I got this one on the 20th when we had all that snow, right? So normally rain has about a pH between 5.7 and 7, so it's slightly acidic. And if it's more acidic than that, it can cause a lot of environmental problems. So the way that we measure acidity is you can use indicator paper like this, right? So to show you how it works, I'm going to put some vinegar in here. So vinegar is a weak acid, but it should be stronger than what we have in there. We're going to take a strip. We're just going to dip it in here, right? And it turns a nice orange color. So I can compare it with this paper, and it looks like this is about a pH of 3, right? So that's a pretty decently strong acid, right? But that's how it works. So now let's test this and just see how. Okay, so this one, I'm just comparing it with again, and it looks like it's about a pH of 7, and that's really nice. That's neutral, right? It's not acidic or basic. We test this one. Right. It's about the same, right? You really can't tell the difference between these two, except for this one's a little bit orange now because I set them together, right? So, right, that's kind of what I expected, right? Is we have nice non-acidic rain, because acid rain really hasn't been a problem in the United States since the 1970s, and that's mainly because of like I said, environmental regulations, especially for plants that burn coal, right? And that used to release something called sulfur dioxide in the environment, and then now they're a lot better about keeping that contained and preventing it from getting into clouds and into the water cycle. Right, so what if you don't have indicator paper? You can actually still do this. You can make your own indicator solution, and this is actually super easy. All you need is red cabbage and hot water, right? So I started soaking this about maybe 10 minutes ago, 15 minutes ago, right? So just red cabbage, a couple leaves that I put in this container with hot water or boiling water. Right, so you're going to want a grown-up to help you with this. But the thing about red cabbage and red vegetables in general is that there's a chemical in there called, or a class of chemicals called anthocyanin. And these are really sensitive to changes in pH. Right, so for instance, let's watch this. As you increase the acidity, it changes color. Pretty cool, huh? It's pink, right? So you can use this. It's not going to give you the exact pH range the same way that, say, this will. This is really sensitive, but will give you a general sense of whether something's acidic, like vinegar, or basic, like, say, baking soda is probably the most common one and the least dangerous basic chemical that you'll have in your house, right? You can also use the indicator solution to make paper, right? Or you're not making paper, you're dyeing paper. So I made a bunch. I got just regular paper and cabbage juice. So you'll notice this one's a different color. I think what happened is that the paper was slightly basic for whatever reason, and so it ended up being more of a blue than a purpley color. Whatever it was used to process this paper change the pH balance, right? But you can make this paper and you can use it to test things. You can also use it to draw on, right? Let's see. So right? Now we have a very nice purple RPL. Right, I also had one that right, it looks kind of gross, right? It has these greenish yellow splotches. That's from baking soda. But so you can use baking soda or vinegar to draw on it. And you can make nice pictures with this kind of indicator paper. Here, let's just for fun, let's see if we can change the color of this going. Right. There we go. So now it's getting purple. We got a little bit more. Now it's getting pinkish. All right, so that's and of course, technically speaking, this is edible, but it's unseasoned cabbage, so it doesn't actually taste really good. And then this isn't edible at all because I added a little bit of rubbing alcohol just to make sure it didn't get gross. So I did that so I could keep this in the fridge and use it again later. You can also just freeze it. But you're not, right, you can think of it like food. So it's not something you want to keep around for a long time or leave out overnight because it'll go bad. Yeah, but that's what I had for you guys this week. I hope you had fun, and I'll see you next Thursday.